Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to continue our topic of basic equations. In our last video, we talked about how to solve basic equations, and if you haven't looked at that video, I would suggest you take a look at that one first, because this video is a continuation of that. We're going to continue with the same processes, but we're going to look at equations that have more going on than the ones in the previous video. So if we take a look at this first example, we're going to encounter grouping symbols in some of the equations that we're dealing with. So I always suggest simplifying each side of your equation before you start moving things around. We can't touch this x when it's in grouping symbols, so you need to get rid of them. So what I'm going to do is I'm going to do the multiplication, get rid of those brackets, and then look to see if there's any other simplification I do before I start solving. So 3 gets distributed to each of those terms. So we're going to have 3x minus 12 equals 2x plus 11. Now we have an equation where we have our variable in more than one term, so we want to get those together. I want to move them so to the side where the coefficient is going to be positive. So rather than subtracting 3x from both sides, I'm going to subtract 2x from both sides, and then my coefficient for x stays positive. So I'm going to subtract a 2x from this side, I'm going to subtract a 2x from this side. 3x minus 2x is 1x. Now I want to get x by itself, and to do so I'm going to get rid of this 12 that's being subtracted, and we learned in the last video to do that. We add a 12, and whatever you do to one side, you do to the other side. So x will equal 23. You can plug it back into your original equation and do a check to make sure that that solution is correct. I chose to do this example because it has a negative here that needs to be distributed, and often students will forget to do that. Whenever you have those grouping symbols, make sure that you apply whatever operation is outside those grouping symbols properly. So in this case, I'm going to be subtracting each term. So when I subtract an r, it's just minus r. When I subtract a negative 3, it becomes plus 3. I can simplify this side of the equation further, so I typically will do that. So 7 plus 3 is 10. I usually like to simplify as much as I can before I start moving terms around. Now I have r on this side and r on that side. I want to combine my terms containing r, and I'm going to do it in a way that I'm going to have a positive coefficient for r. So I'm going to add r to both sides. So I'll be left with 10 minus 0 equals 5r plus r is 6r. You can leave your variable on the right side of the equation. A lot of people are more comfortable if it's on the left side. Because in math, we can switch this. It's called the reflexive property. You can do that if you prefer. It's not necessary, but if you like to have your variable on the left-hand side, just change it, just flip it. That's allowed. Now I'm going to isolate r by dividing by 6. If I do that to the left side, I need to do it to the right side of the equation. 6 cancels, and I'm left with r equals 10 over 6. I like leaving things exact, but I also like to have it reduced. So 10 over 6 can reduce to 5/3. So that would be my solution. I would prefer that rather than someone writing 1.6666, repeating, or 1.67, or however you choose to round it off. I like exact answers. Let's take a look at some more. I'm going to actually have a video on fractional equations coming up, but right now we can handle this without understanding all of the concepts involved with solving fractional equations, because I know already that when I have dividing by 5, which this line represents division by 5, I can get rid of that grouping symbol or that operation by doing the inverse of dividing, which is multiplication. So what I'm going to do in this equation is I'm going to multiply both sides by 5. So if I multiply this side by 5, the 5 will cancel. I need to do this side by 5 as well. So the 5 will cancel, and that gets rid of that division, and I'll be left with 4m minus 2 times m plus 4 equals 10. This is a lot more manageable to work with. I couldn't touch anything in that numerator while I had that division by 5 because it's like it's in brackets. That whole numerator is in brackets. I still have brackets that I want to get rid of because I can't touch that m or that 4 while I've got the grouping symbols. So that will be my next step. I'm going to distribute that negative 2, so it's going to be minus 2m, and a minus 2 times a positive 4 will be minus 8. I can combine my like terms, so 4m minus 2m. Now it's a much more manageable equation. I solve as I did in my previous examples. I want to move the 8, I want to get this term by itself, so I want to move the 8 to the other side, and to do that I add 8 because it's being subtracted, and I have to do the same to the other side. So I'll be left with 2m equals 18. Now I need to get rid of that 2. That's multiplication, so I divide, do the same thing to the other side. 2 will cancel, so I'm left with m equals 18 divided by 2 is 9. So it didn't look nice to start with, but if you get rid of that denominator right off the bat, then it became easier, and then work with the next grouping symbols and so on. Let's take a look at 2 more examples dealing with our grouping symbols. I wanted to do an example that had decimal values in it just so that you understand the process is exactly the same. It's just not as easy working with decimal values as it is with whole numbers. But we still have to deal with the grouping symbols. We can't touch the terms inside of it while we've got an operation outside of it. So we're going to distribute that operation, which is multiplication. So we're going to have 2 times 1.4x will be 2.8x. Minus 2 times 2.3 will be 4.6 equals 6.8. Now I'm going to simplify this side of the equation because I have some like terms. So I always simplify before I start moving things back and forth. So I have 5.1 minus 4.6. So I'm going to write my 2.8x. I'll write that term first. And then 5.1 minus 4.6 will be 0.5, 0.5. Always put the 0 in front. If you don't, sometimes people miss the decimal point there. So be in the habit of putting a 0 in front of a decimal value if there is no number there. Just it points out that that's a decimal. Now I want this term by itself, so I want to move the 0.5. I want to get rid of it. To get rid of it, it's being added. I have to subtract by 0.5 or subtract 0.5. So I do the same thing on the other side. So I'm going to have 2.8x equals 6.8 minus 0.5 will be 6.3. And then to solve this, I'm going to divide both sides by 2.8. Will cancel, and my answer is 6.3 over 2.8. That is not considered simplified. When you have a decimal in a numerator or a denominator, you need to deal with that. So what I'm going to do is I'm going to multiply numerator and denominator by 10 so that I get rid of my decimals. So that's going to be 63 over 28. And remember, anytime you're dealing with fractions, you always want to see if it can be reduced, which means, is there a common factor in both the numerator and the denominator? So we can think of 63 as being 7 times 9, and 28 as 7 times 4. So we have a common factor of 7 in the numerator and the denominator that we can cancel, and that reduces to 9/4. So x equals 9/4. is the way I would express it. Because that changes to even decimal, you could, if you prefer, express it as a decimal. So the decimal would be 2.25. That's not rounded off, it's exact, that's exact. Okay, our last example has quite a few grouping symbols, and it's actually very similar to the example that I started the last video with. We didn't solve it at that time because I wanted to build up our skills in solving equations first, but I think we're ready to tackle it. You want to eliminate any grouping symbols and simplify, and then we start worrying about solving. So I start with my innermost brackets and deal with that, and then I go to my outermost brackets. Once I eliminate all of those, then we'll take a look at what we're left with. So I'm going to leave this here, and I'm going to distribute that subtraction to each of those terms. So that would be x minus 4 minus minus is plus 3x. Now I can simplify within those brackets, so I might do that first. I just find that much easier than starting to apply other operations and having more terms than are necessary. So I'm going to simplify that. I'm going to have x plus 3x, which is 4x. I still can't touch either of these terms because they're in those grouping symbols, those brackets, and I have an operation to apply. So I'm going to do that next. So I'm going to distribute a negative 2 to each of those terms. So negative 2 times 8x will be negative 8x. Negative 2 times negative 4 will be plus 8. There's nothing I can do with the right side. There's nothing to simplify there. And one last step, I'm going to combine like terms. So 5 plus 8 is 13. Now I've got an equation that's much simpler, and I can start rearranging things and moving things around. In this case, I want my x terms to have a positive coefficient, so I'm going to get them together by adding an 8x to both sides. So I'll be left with 13 equals 10x minus 4. I want to get this term by itself, so I'm going to add a 4 to both sides. So 10x is equal to 17. And again, I can write that as 10x on the left-hand side. Now I want to solve for x, so I'm going to divide both sides by 10. The 10s will cancel, and I'll be left with 17 over 10. And that can easily be expressed as 1.7 because that's exact. So either of those answers would be correct. My next video is going to be on literal equations. So have a good understanding of working with equations that have numbers in them, because the process is the same when we look at literal equations or formulas, but we can't simplify as much, so it does look more complicated. But until then, practice as many of these as you can till you get very confident and comfortable, and then we can move on to the next video. Take care and see you then.